Welcome to the Complete Engineering Podcast, brought to you by the University of Nebraska-Lincoln College of Engineering.
All right, welcome back to the Complete Engineering Podcast. I'm Carl Vogel, your host. Today we're going to talk about artificial intelligence and robotics. And the impetus for that is we have two researchers joining us today who have been part of a Netflix docuseries that is coming up. And we are joined today by Bradley and Benjamin Riggan. Welcome today, gentlemen.
Thanks. Nice to be here.
Thanks. And let's just start with some of the basics for those of us who are like me and don't understand everything there is to know about artificial intelligence. What is artificial intelligence, and how are the two of you incorporating it into the research that you're doing?
I start with that. I suppose I'm going to say quite a few things here to try to set the stage for further discussions down the road. So one important thing, like a lot of things in academia, there's not really an agreed upon definition of artificial intelligence, or AI as we call it. In fact, in what's the most influential book on AI, there's several pages devoted to various definitions that lie along a spectrum. But I think one of my preferred definitions is from a paper from 2004. And basically it says AI is the science and engineering of making intelligent machines, especially intelligent computer programs. So basically you can think of that like making machines do something that we might think of as intelligent. But I think there's a little more to the story, because I don't think that's really what people are thinking about in relation to where we're at right now in the world. Most people are really thinking about generative AI, like ChatGPT, and it's composed primarily of artificial neural networks, or often we just call them neural nets. So neural nets are basically collections of connected functions that loosely model neurons in a biological brain. And the neural net gets trained with data that uses a variety of techniques that allow it to infer a model. And I think this is pretty important to mention here, because it somewhat distinguishes the very basic definition that I gave just a minute ago, which encompasses all kinds of things we've been doing for years, for decades in robotics and computing. And it differentiates it from that and what often gets discussed in news articles and what underpins the technology most people are thinking about when they hear about AI. I think it's also important because in the Nimbus lab, we've been employing all sorts of techniques from AI in its broadest sense for a lot of years. But again, probably not what people are really thinking about. So to narrow it down to sort of the use of deep learning of artificial neural networks, which again is sort of the underlying technology that empowers the most advanced AI. In Nimbus, we primarily use this for classifying things in imagery, and AI has shown itself to be very capable of doing this. So just for an example, we've recently showcased some of the work we did with Dr. Riggan here, where we used an onboard camera suite to identify drones flying in the air. So this has applications in being able to detect drones with potentially nefarious intent. We also use AI, I think, in a somewhat unique and novel way. So drones have onboard algorithms called controllers, and the controllers send signals to the motors that move the drone to a desired location. And the design of these controllers has been around for over a century and are firmly rooted in mathematics, but they have limitations. And so recently researchers have used a strategy in learning and training neural nets called reinforcement learning, to design controllers that can do a bit more. So in our most recent swarm work, we use a strategy to learn, such a strategy, I guess, to learn a safe controller that can separate a swarm of drones into subgroups and then control each group to a desired location. So kind of give you a taste of several different aspects of how we incorporate it into our research.
Right. And Ben, artificial intelligence has been pretty important in the work that you've done in your career as well.
Yes. Yeah. And I would say just how I would classify artificial intelligence in the work that I do specifically is that it can be used to tackle broadly two types of problems. It can tackle things that humans can already do well, but the AI can do it much more efficiently with greater throughput. Or it can be used to do things that humans can't do well at all. And so some of that we'll talk about as we dive down to specific things. But largely in my work, I use AI for perception, for image and video understanding. That's getting a computer to understand complex patterns that are within those images and videos. More specifically, I work in an area, a subset of AI called domain adaptation. That's where trying to bridge the gap between very diverse types of patterns, such as thermal imagery, visible imagery. The patterns in those types of two types of imagery are very different. And so other types of problems and challenges that I apply AI to is to understand the physics of imaging and optics. And so this can be very helpful for advancing not just the low level AI, but developing the applications around, building applications around the AI system. Other things that I've worked on, again, using my background in optics and understanding the physics as well as the artificial intelligence, is in applying AI to using imaging systems in agriculture to identify weeds, tracking all types of tracking activity, particularly with like livestock, and assessing the health of livestock. And so there's broad applications for AI, but it all boils down to getting reliability and speed out of these AI systems.
Right. And what is Justin? Much of your research is on what are known as unmanned aircraft systems, or UAS, and we might refer to those as drones, and those, a lot of us have those to fly around and little things. But you're talking about sometimes maybe bigger drones, small than the average public would have, or more sophisticated. How, in general, how is AI becoming more prevalent in this field?
Yeah, so we've kind of accepted that drones is going to be a word people are going to use. So feel free to use as you need. So yeah, great question. So in the narrow sense of generative AI, which I kind of mentioned is what people are, I think, primarily thinking about when they talk about AI. And this is, again, what's in Chat GPT. AI is pretty rare. That kind of AI is pretty rare in these types of vehicles. There are a couple of main issues. One is that this type of AI requires extensive computational resources, and often we just don't have that kind of computation available in the types of small, lightweight packages that we put on drones. And the requirements for more computation are growing larger and larger as the neural nets get more and more complex. So the sort of the direction that AI is moving with larger, more complex neural nets doesn't translate well to small robotic vehicles that have limited onboard resources. So in that sense, it's not growing very rapidly for the complex neural nets that are being developed. On the other hand, there are a lot of people sort of simplifying these down, trying to figure out how you can prune out the parts of the neural net you don't need, and then make them fit within the computational resources. There's one other issue. The other issue here is that most robots are safety critical machines. So that means they have to be shown to have safe, guaranteed performance. So if you think about a drone, flying over the ground, this needs to be guaranteed to be safe for to be flown and over people and whatnot. And most AI based on neural nets just doesn't have the guarantee of being safe and secure. So in fact, there's an entire growing field of study that's dedicated to establishing the safety of different types of neural nets. But there's a lot of work to be done. And as of now, most neural nets can't yet be shown to be provably correct or safe. And so at least in the drone world, there's a reluctance to sort of let them go closer to the decision-making point, and I can talk more about that in a minute.
Yeah. Now, Justin, you and Ben have worked together on a project, correct? And what is that project, and how did that come about? Ben, maybe we could start with you explaining.
Yeah. So Justin and I kind of teamed up, and so using some of my colleagues from the Army, we started having a conversation. One of my Army colleagues mentioned that he was interested in swarm robotics, and so I said, well, we've got a lab here at University of Nebraska, the Nimbus Lab, and I said I can certainly set up a conversation. And so that's sort of what started off this project. The Army had some control algorithms, some swarming algorithms that were very much early stage in the works, and so they wanted to kind of see that get matured quite a bit into some field demonstrations, and so that started the conversation to some of the work, and then as the conversation evolved, where I kind of fit into the picture was, it's great that people could see these swarm robotics flying around, but it's hard for them to actually see, what's actually going on under the hood. So that's where we talked about adding some perception to the swarm robotics, and sort of just applying some of my expertise into the project to give a use case to the algorithms. And that project involved quite a bit of challenges in terms of, because there was all kinds of assumptions underlying the algorithms that just made it really difficult to deploy. And I'm sure Justin can talk a little bit more about that. But that was really how this project got started. And it was all geared towards identifying other drones, because I think there's a lot of interest in both commercially and for military applications to be able to detect these small objects that are flying from a safety perspective.
Yeah, so just to piggyback on what Dr. Riggan has mentioned here, so the Nimbus Lab is pretty good at deploying vehicles out in the world. A lot of people in this space of robotics deploy them inside under different circumstances that enable them to use a camera system to enable location information, and they often use Wi-Fi to sort of communicate. And so the big challenge here was taking the complexity of a swarm and moving it outside to build a test bed where we could test out various swarm algorithms in the wild, sort of out in real conditions. And there's a difference there, and the people who have deployed things out in the world sort of understand the challenge there. And so we did, there were a lot of challenges to overcome, a lot of assumptions that were made, that are made when people design things that then don't get translated very well into sort of real world deployments. So we built a test bed, a swarm test bed. We have two, what we affectionately call mothership drones that each of them carries 4 smaller drones, and takes them to a specific location and then drops off the small drones. The small drones can then coalesce into a group, and they can do various tasks either as a group, or we also have some fairly fancy AI that we developed in collaboration with the Army to separate the group into smaller groups and go and perform various missions. And as Ben mentioned, where his work comes in nicely is the ability to perceive potentially other bad actors, other drones in the sky that are potentially dangerous or being used for nefarious purposes. And that really is an outgrowth of the fact that these vehicles have become very popular and very prevalent and easy to buy, and they're also easy to modify. And the result of that is that we need to be able to detect and identify if there's a potential threat there, not just on the military side, but on the civilian side as well, and do something about it, detect that, and then put the decision into the hands of decision makers who can decide what to do.
Definitely. You're talking about decision makers and policy makers as well. And Ben mentioned earlier that he had military colleagues in previous projects. How did you get involved in working with these types of projects with the military, and what sorts of things have you worked on outside of the Swarm project here with Justin?
Yeah, so my first exposure to working on defense related projects goes back to my graduate school days. My advisor was a program manager for some of these defense agencies, and so he had a large network in the defense community. So naturally, that funded me as a graduate student working on these projects. That ultimately led to my early career transition, where I had the opportunity to work at the Army Research Laboratory, where I helped develop and do research on the next generation technologies, things from sensors and optical devices to developing some early stage artificial intelligence for those new higher quality systems. And so that opportunity really just exposed me to a whole broader understanding of the defense community and its needs. And this helped me sort of, as a scientist and an engineer, develop new technologies, new algorithms for those systems. And ultimately, I came to University of Nebraska in Lincoln with a lot of these ideas. And so that was really my first exposure, and sort of all through graduate school, through my early career, just sort of growing this level of understanding and exposure.
Right. And some of the work that you did with the ARL is related to a lot of the work you're doing here. And I speak specifically of a project that we discussed for an article I wrote about not just facial recognition, but body recognition, that we're talking about, that the military, the Defense Department may be interested in. What sorts of things are going on with that project, and why is that something that's a positive for people, and why should we be happy that the military is developing that? Maybe I should ask that question better.
Yeah.
What sorts of things about that facial recognition and body recognition things are a benefit to us as individuals here in the state and in this country?
Yeah, so I worked on facial recognition at ARL, specifically nighttime facial recognition. That is, since I've transitioned to Nebraska, been working on whole body recognition, especially at long range. So all of these technologies, they lead to better public safety, better national security, is sort of the goal. These are very far-reaching technologies. It goes to understanding the optics and the physics involved with capturing an image. So I think, from the public standpoint, you want these technologies to be pursued, because they're already being pursued by other groups. So I think the inaccuracies that are currently there, when somebody just isn't looking at the camera, or a profile view, these fundamentals need to be understood, so that somebody making a decision isn't going to just blindly understand what, take at face value what the algorithm is saying. So that's part of my role in working on these technologies, is to reduce those inaccuracies and make them better, again, contributing to better public safety, better national security, um, and but also just bring about awareness of what mitigations can we make uh, when these algorithms do make mistakes, as they often will.
Right. And Ben, you mentioned earlier, just a few minutes ago, about the experience you had as an undergraduate student that helped form your career. And I know both of you involve a lot of students, both undergraduate and graduate students in this. And what experiences are they receiving in this? And how are you involving them in these projects so that it's going to impact their careers down the road?
Yeah. So specifically on my side, I intimately engage students with data collection opportunities to just analyze data. And so I can do that as early as high school level. I have high school students that are part of my lab that help us curate data that go into the development of a lot of these algorithms. Undergraduate students do some of the data analytics that happens after an algorithm is designed to help us gather sort of post analysis type data to help us better design the algorithm. The graduate students, once they have better understanding of the physics, of the mathematics involved in designing these algorithms, they're able to actually make changes to these algorithms to make them better. So it sort of, at every experiential level, there's opportunities to involve students in this type of work.
And Justin, with you, like the Nimbus Lab has gotten quite a bit of attention for a long time. And how are students benefiting from the work that they do, not only with your projects, but through the Nimbus Lab?
Yeah, so I think one unique aspect that we have in the Nimbus Lab is we have an NSF-funded REU site. REU stands for Research Experience for Undergraduates. And basically, we have 10 to 12 undergraduate students from around the country come to the Nimbus Lab to conduct a 10-week research program or project. And that is interesting for a couple of reasons. One is that in addition to what our graduates do during the academic year, their normal research, during the summer, they get to be mentors to these REU students. So they get to help lead undergraduates in accomplishing their research objectives. And this helps them learn about how to manage groups of people and how to work with sort of people who are working together to accomplish a larger group objective. On the undergraduate side, this obviously gives a fair number of students the opportunity to come learn about the Nimbus Lab. So there's an opportunity there to try to recruit them back to the university for graduate work. In addition to this, we have a number of undergraduate opportunities during the academic year. We typically have about 5 to 10 undergrads in the lab at any time, and they are not sort of just doing what you might think of as grunt work. They're not just turning screws. They are also doing research. They're writing papers. We have a lot of undergrads whose names get on papers because they made significant contributions to the research side. And that has worked out really well for us, not just for recruiting, but we enjoy working with undergraduates in their formative years. One final mention, we also are involved in a STEM Connect program. And the STEM Connect program gives opportunities to disadvantaged students, rural students, students from underrepresented groups, and helps them with scholarships to conduct research as well. And we have several of them in the Nimbus Lab as well.
And it seems like all of these things are coming together and helping to make Nebraska become a leader in the fields of not only AI but robotics as well. I think both of them have become a big deal. What sorts of things are making this a go-to place that would have documentarians coming here to talk to our researchers and students wanting to come here and work? What is it about Nebraska that's such a great place for these things to happen?
Yeah, so the Nimbus Lab, as I mentioned, has a really strong reputation of deploying robots in real world scenarios. And that means putting them in the hands of people who are going to use them. It means adapting them to work outside in real conditions. And this just isn't super common, as I mentioned earlier. And the result of that is that it gets people's attention. So one of the things that we do is we try to make videos of the kind of technology we deploy, and we try to make it known that we are interested in the impacts of real world application. And just to give you a little bit of an idea of what that looks like, we learn a lot by deploying our vehicles outside. We collect a lot of data about how they communicate, the kinds of errors that exist in positioning, the kinds of things that can go wrong in software and hardware over the course of many deployments of these vehicles over time. And what we do is we take that information and we learn lessons from it, and we then reincorporate those lessons into the research that we do, the foundational research, building the autonomy that we put on the vehicles. And this is a really significant loop, sort of learning from real deployments outside and then incorporating that into the foundational research we do. And people are taking notice. And so, one thing that has been a big boost for us is winning the Heartland Robotics grant that came through last year, where the U.S. Department of Commerce gave the university $25 million of grant funding to develop an AI and robotics area here at the University of Nebraska and within Nebraska at large as well. We've also done really well with developing a culture here of being the Silicon Prairie, where there's a lot of leading edge companies that are developing interesting technology that impacts the world largely.
And Ben, what specifically would bring you to Nebraska and make you want to be a part of what's growing here?
Yeah, I think it's just the ability to bring these really difficult problems that I know that the students from the state and surrounding regions that Nebraska recruits from, like, they have the skills and the capabilities of tackling these large, difficult problems that, as Justin mentioned, taking stuff and making it happen in real time and having this huge impact. And so that's largely what attracted me to Nebraska. Just enormous opportunities and capabilities, and so just being a part of that is just amazing. The fact that we're pushing to do recognition out to 1,000 meters with conventional optics is it's a difficult problem that students are really inspired and motivated to work on. Yeah.
And in the future here at Nebraska is going to grow. I mean, we're seeing robotics and AI being a huge part of that growth. And what's next for the two of you in your research and the work you're doing, and where do you see your work headed in the next few years?
So for me specifically, a lot of my work has started to take a lot of the knowledge from the defense community and start to apply it here locally in Nebraska by working with law enforcement and criminal justice systems and applying that technology, because a lot of the same AI that goes into the recognition systems and the biometrics that I utilize in my work is also applicable to those systems. But there's a lot more understanding of the legal system, and so being a part of, again, contributing to public safety and security, that type of application, but more locally rather than here in Nebraska, rather than nationally or even internationally.
And Justin, what do you have on your horizons?
Yeah, so a couple of years ago, when we undertook the development of the swarm, the thought and sort of the calculation was that swarms would be an important part of robotics going forward and would allow a new set of capabilities. And so 2 years later, we are now starting to realize some of those capabilities. We have a couple of projects starting up. Just to give you an idea of a couple of them. So swarms can be used to do a lot of things. They can deliver supplies to frontline soldiers. They can track targets of interest over a wide area. Swarms can also be used to help landowners and farmers in precision agriculture. So one of the new projects we've got starting up is a swarm that's composed of drones where each has a different set of capabilities, and they'll be deployed to efficiently and automatically help companies and landowners identify how much carbon and water they have in their soil. It's a very manual process to go out and sample a large piece of land for carbon and water. And so this would automate all of that. And in the emerging market of carbon sequestration, this can help landowners know how much they can expect to be paid for leaving their carbon in the ground in an effort to curb greenhouse gases. We have another project where we're using kind of a similar multi-robot technology to deploy drones and robotic boats and robotic underwater sensors to track beavers and their impact on climate change in Alaska. So a lot of good projects upcoming that are sort of on the civilian side to help improve landowners' ability to manage their land and help combat climate change over the long run.
All right, you guys are on this cutting edge, this leading edge of work here that's helping make Nebraska a leader in this field. And I want to thank both of you for joining us today on the podcast. I want to thank the audience who've been with us today, and I want to remind everybody to check out the other episodes of the Complete Engineering podcast on the Nebraska Engineering YouTube channel and on our major podcast hubs out there. Justin, Ben, thank you again for joining us.
Thanks so much.
Thank you.
All right, everybody, have a great day.
Thank you for listening to the Complete Engineering Podcast. For more information, visit us at engineering.unl.edu.
All right. Now, some people are very concerned about the growth and pervasiveness of artificial intelligence in our world. Justin, as an engineer and a scientist, what are your concerns about AI, and how do those concerns affect your research?
Yeah, so I think the concerns the public may have, which are probably influenced in large measure by Hollywood's many AI and robot movies, tend to be a little different from the concerns we have as engineers. So personally, I'm much less worried about making Skynet or HAL 9000, and much more worried about people using robots for nefarious purposes. So for drones, we've already discussed this a little bit, but this has already been a problem in the form of all kinds of weaponry being strapped to it. So this worry has been in large part why the government has concerned itself with funding counter UAS technology and development so that we can identify drones that are potentially bad actors. But as robots become more capable through both neural nets and more traditional AI, their ability to be used poorly will increase. And in some sense, these are just normal concerns associated with any research area. And one way that I think this is being combated is with well-focused rules from the FAA. So just as an example, in the real near future, remote ID is going to be required on drones so that they broadcast important information, including position. So I think some of these like common sense rule making that has the potential to keep the skies and grounds safer and can help keep drones out of the hands of bad actors. There's a couple of other things I wanted to mention, more specific to neural nets in robotic vehicles like autonomous cars or drones. The biggest concern I have is the use of neural nets that creep further and further, what I call into the loop. And by this, what I really mean is that the AI, rather than being deployed in a way where its decisions can be easily safeguarded and checked, it's moving closer and closer to the decision point without sufficient guarantees about its performance. So there are many cases of autonomous cars misidentifying things they observed and then making the wrong decision based on that misidentification. And neural nets have this way of operating consistently and flawlessly in very complex scenarios. And then they have this way of failing in spectacularly dumb ways that a person likely wouldn't. And sometimes this just happens. And what this really means is that the model that was learned from the data was not quite right. And the problem there is that there's not really a good way yet to know in advance whether it learned the right one or not. So until we can sort of show that the AI has learned a correct model, not sure we should be allowing those AI algorithms anywhere near the decision point in our robotic vehicles. One last issue that I think is worth discussing. Right now, it does seem like a very small set of technologists at a few very large companies are making most of the decisions about where, when, and how AI gets deployed. And I'm not sure that that's a great idea. I think it's a symptom of a wider problem in technology that's been growing for some time. But bottom line is that we need robust laws and certification standards, or at the very least, strong guidelines about how these get deployed in robotic vehicles. At least in Nimbus, we try to be part of the solution by thinking carefully about the kinds of projects we take on and focusing on providing benefit to scientists, farmers, landowners, and the public generally. And we certainly push technological boundaries because it's research after all, but we also obey all the FAA rules for every test flight we conduct, and we have a lot of backup systems and fail-safes to keep everyone safe.
And Ben, I'm sure there are a lot of things that you have to take into account with your research, especially the recognition type work. What sorts of concerns do you have about AI, and how do you address them in your research?
Yeah, definitely. With biometric recognition using AI, I think the most prevalent concerns that I have, and a lot of society has as well, are issues around privacy, bias, and just the responsible use of the recognition technology. They are always at the forefront of my mind. And so to me, the biggest issue around these technologies is some of the inaccuracies and in these recognition systems. The false identification rates have huge implications, especially in defense and law enforcement applications. But I think by focusing on reducing those false identification rates, we can better understand the implications of these privacy bias concerns. The other way that I combat these issues are by always acting responsibly in the type of data that we collect. We always have to go through strict IRB reviews and human subject consent procedures. So we are very careful to make sure that everybody involved in our projects understand what we're doing, why we're doing it, and how their data is going to be used. So this is I think privacy is one of those key issues. But the thing is the technology is already out there, and a lot of and it's making a lot of waves. But I think the thing is it's currently deployed with a lot of inaccuracy. So to me, by addressing those inaccuracies is part of my main motivation. But while also building in safeguards, we need to address there's a lot of AI has advanced so rapidly in this area that the laws haven't really caught up. A lot of the privacy laws are dating back to the 60s and 70s that are, um, you know, dictating a lot of the work in this area. So, I'm intimately involved in the IEEE digital privacy, um, you know, team, and that is trying to engage some of the issues around digital privacy. Uh, but there's one reaction in this space, which is like, let's ban all the technology altogether. But going back to my previous point, that this technology benefits public safety and national security, you don't want to make those down to zero, right?
Right.
At some level, we all want some responsible use of this technology for those things, but we don't want them to go unchecked. So using the technology, understanding the technology to build in certain safeguards, kind of what Justin alluded to in the robotics space. We want to do the same thing in the recognition space.
Definitely. And a lot of people, like Justin mentioned, that there's a lot of public concern about AI, and how much of that do you think in the public's knowledge of what AI is misconceptions or just not being educated well enough?
Yeah, I think, Hollywood does play a role into what we can do. But, even within some of my projects, with the long range recognition or the nighttime recognition, yes, we've made great strides in those problems, but to say that I'm going to be able to pick out and identify one person out of 10 million, we're not there yet. But I would say Hollywood would make us believe that we are.
Definitely. Yeah. And Justin, are there areas in the use of robotics that people are probably not conceiving that how they're truly being used?
Yeah, so I think, as Ben mentioned, the biggest issue here is the false identification rate, and this extends to beyond just image classification. So if you use AI for control in a robot to control the vehicle, there are similar false outputs from the neural net. They're just not identifying something. They're providing control inputs. But the problem here is that it happens, and you don't know why necessarily, and you can't always predict you can't predict often what inputs will lead to those incorrect outputs. And so again, what this means is that robots can end up using AI and do things that our traditional autonomies have not been able to do. And then they will have these failures that just seem incomprehensible, and you don't understand why it made this like really poor decision. And so there's this whole field growing to be able to do this, to be able to tell when the outputs are going to be correct and when they won't be. And I think that field needs to grow. And it is already receiving a lot of attention. But I think the public should know that, we are aware of this and know how this, the impact this has on robotics, and are working hard to try to make sure that what we put on board a robotic vehicle is safe and will be used responsibly.